So the second type of simplest trigonometric equations are equations of this type. Sin square theta is equal to sin square alpha. Cosecant square theta is equal to cosecant square alpha. Cos square theta is equal to cos square alpha. Secant square theta is equal to secant square alpha. Tan square theta is equal to tan square alpha. Cot square theta is equal to cot square alpha. So what the difference between type 1 and type 2 is, type 1 does not have squares, type 2 have squares. So now let us take an example and see how the equations of this type can be solved. So for example, if sin square theta is equal to 1 by 2. So you need to solve this. You need to find the general solution for this. So 1 by 2 can be written as 1 by root 2 whole square. And 1 by root 2 is nothing but sine of 45. So this is sine square of pi by 4. So sine square theta is equal to sine square pi by 4. Now I'll try to solve this equation. So sine square theta is equal to 1 by 2. This implies sine theta is equal to either plus 1 by root 2 or minus 1 by root 2. So sine theta can be either plus 1 by root 2 or minus 1 by root 2. So now sine theta is equal to plus 1 by root 2 became the equation of type 1. Sine theta is equal to minus 1 by root 2 is also an equation of type 1. So the equation of type 2 contains two equations of type 1. So if you draw the quadrant diagram for sine theta, so now sine theta is equal to 1 by root 2. The quadrant diagram is plus, plus, minus, minus. So sine theta is equal to plus 1 by root 2 in the first quadrant at 45 degrees. And in its allied position in the second quadrant, 3 pi by 4. So these two positions give you sine theta is equal to 1 by root 2. Now sine theta can also be equal to minus 1 by root 2. That means this position as well as this position also comes. So in one rotation you have four positions which satisfy this equation. So what are the answers that you have? Theta can be equal to plus or minus pi by 4, right? And pi plus or minus pi by 4. Next, one complete rotation plus or minus pi by 4. 1.5 rotation plus or minus pi by 4. 3 pi plus or minus pi by 4. So on. So all these are solutions to this equation. And how do I write this in a general form? So theta can be written as n pi. You're getting all integral multiples of pi plus or minus pi by 4. So pi by 4 is nothing but this angle alpha. So whenever you have an equation involving squares, so what you try to do is, let us try to express sine square theta and is equal to sine square of some number alpha. So whatever number is given, you have to express this in the form of sine square of alpha. You have square here. And the answer will be n pi plus or minus pi by 4. And the interesting thing in type 2 is, this solution works for all these equations. So let us see why this happens. So if you have cos square theta is equal to cos square alpha, if you have cos square theta is equal to 3 by 4. So what is the quadrant diagram for this? So this implies cos theta can be equal to plus or minus root 3 by 2. You can have plus root 3 by 2 or minus root 3 by 2. So the quadrant diagram is plus, plus, minus, minus. So corresponding to plus root 3 by 2, you have plus 30 degrees and minus 30 degrees. And corresponding to minus root 3 by 2, you have the allied positions in the next two quadrants. So effectively the quadrant diagram looks exactly same as the quadrant diagram for sine theta. And similarly for tan also. So tan is positive in the first and third quadrants, negative in the second and fourth quadrants. Corresponding to tan theta is equal to positive square root, you get roots in these two quadrants. Negative square root, you get roots in these two quadrants. So here also the quadrant diagram looks exactly same. That means in one rotation you're getting 4 solutions. In type 1 you have got only 2 solutions per revolution. So here you have again 4 solutions exactly same. So you have the solution for all of this in the same form. So for all these types of equations, the solution looks like theta is equal to n pi plus or minus alpha. So whenever you see equations involving square, the solution is n pi plus or minus alpha. So if you take another example, so you need to solve tan square theta is equal to 3. This is in the type 2 form. That is, you have a square for trigonometric ratio. So tan square theta is equal to 3. So what you need to do is, you need to try to express 3 as some tan square of alpha. So 3 is nothing but root 3 whole square. That's nothing but tan pi by 3 whole square. So tan square theta is equal to tan square of pi by 3. And from now you don't need to do the derivation. So you can directly write theta is equal to n pi plus r minus pi by 3 as the answer. So every equation of this form has the solution of the same type. So theta is equal to n pi plus r minus pi by 3 is the solution. And for equations like this, in one rotation, you get 4 possible answers. So if you were asked to find the principal solutions, you get pi by 3. So you have 4 positions like this which work for this equation. So pi by 3 is one solution. Pi plus or minus pi by 3, that is 2 pi by 3 as well as 4 pi by 3 is a solution. And next you have the solution in the fourth quadrant, 2 pi minus pi by 3, that's 300 degrees, which is 5 pi by 3. So all these 4 are the solutions, principal solutions to this equation. So I hope you have understood the type 2 questions. So now let's go for type 3 questions.